This section will provide a brief introduction to some of the SMR challenges which we will be discussing today. According to the International Atomic Energy Agency, there are currently over 50 different designs for small modular reactors today. Here we can see a map which shows just a selection of current reactor designs. Countries such as Russia, China, the United States, and South Korea are most actively involved in SMR development. While the benefits of SMR technology have been well advertised, it is important to remember that SMRs will still require effective management, monitoring, and verification, just like a traditional large nuclear power plant. As with any use of nuclear materials, the risks of diversion and misuse remain a constant threat and proliferation challenge. This is why it is important to ensure that SMRs are safe, secure, and proliferation resistant as possible. SMRs is how to respond to an accident or changing environmental conditions. There is concern that there has been insufficient study and research in this area, and that countries importing the technology do not have experience in this area. It is important to consider that many of the countries considering SMR technology have little or no previous experience with nuclear energy, so may not have sufficient safety and security knowledge and experience to operate SMRs. Another area of concern is that if there are vulnerabilities in the reactor design or management procedures, this could be exploited by state or non-state actors seeking to develop nuclear or radiological weapons. If SMRs are deployed in many countries, this will greatly increase the burden on the activities of the International Atomic Energy Agency, particularly in the area of inspections, verification, and monitoring. In addition, the IAEA will have to help new nuclear markets to strengthen their national legislation and infrastructure related to nuclear energy. Emerging nuclear markets will often lack the facilities needed for the safe and secure use of nuclear fuel, including manufacture, storage, and waste management. This will require a lot of transportation of nuclear materials, which is one of the most vulnerable areas from a proliferation perspective.
So now let's look at exporter-importer market of SMR and non-proliferation issues. Future is adapting non-proliferation approaches to the changing world because this should be taken ahead of the import of new technology by nuclear aspiring countries. Future is something not really certain because the leadership is quite amazing. When we look at the number of SMR developed now in the world, Russia is leading, followed by US, Japan, China, and so on. The leadership of Russia is something going through Russia, Africa Summit, Russia, Asia Summit, where Russia is developing a network where they can share nuclear technology with aspiring countries. When we look at the challenge of the market, so the commitment of importing country to IAEA safeguard verification should be part of the trust building toward the international community. Be fixed or should be explained by what we call the growth of the population of the world. In the near future, Africa and Asia will be the most popular continent in the world, so they are going to be the largest market.
In this section, I'm going to talk about the SMR's design risk. You can see in the table a comparison between the 4 different SMR types: the water-cooled, the high-temperature gas-cooled, the fast reactors, and the molten salt reactors. You can see the technical characteristics for the 4 types: the fuel enrichment, the refueling intervals, and the waste volume compared with the large reactors. The linkage of nuclear power to the potential for weapons proliferation stems mainly from the uranium enrichment and from the spent fuel reprocessing. Proliferation resistance is challenging. Example for that, one way to lower the risk of diversion from nuclear reactors is to minimize the refueling frequency, because these are the periods when the fuel is out of the reactor and most vulnerable to diversion. In order for the reactor to maintain the reactivity for long period between refuelings, it would require fuel with higher enrichment or mix the fuel with plutonium. Therefore, any any reduction of proliferation risk at the reactor site by reducing refueling frequency will be accompanied by an increase in the proliferation risk elsewhere. In case of impact pressurized water reactor and fast reactors, the proliferation risk is enhanced relative to current generation light water reactors primarily, because greater quantities of plutonium are produced per unit of electricity generated. In case of STGRs, the proliferation risk is increased because of the use of fuel with higher level of uranium enrichment, but is diminished because the spent fuel is in a form that is difficult to reprocess. In case of molten salt reactors, the continuous processing of fuel, which is integral to the reactor operation, could facilitate the extraction of weapon usable materials, plutonium or uranium-233 from the.
This final section will cover some of the policy recommendations which may help to increase the safety, security, and proliferation resistance of SMRs. Dialogue is important. Current initiatives such as the International Atomic Energy Agency's Small Modular Reactor Regulators Forum provide a model for expanding future discussions to focus more on the safety and security aspects of SMRs. Another recommendation is to put SMRs high on the agenda of the International Atomic Energy Agency. It is also important that the International Atomic Energy Agency ensures that safety and security guidance outlined in its Information Circular series reflect current developments in nuclear technology. To reflect the increasing demand for nuclear technologies, states should commit to providing increased resources to the IAEA. Particular areas which need to be expanded include safeguards, monitoring, and verification. Increased research and development of remote monitoring technologies such as use of satellites, autonomous systems, and artificial intelligence should also be considered. SMR manufacturers and exporters should share best practices when it comes to producing proliferation-resistant SMR designs. It might also be helpful to create a risk analysis profile of each importer country in order to consider which design is most appropriate for the in-country safety and security conditions. It is important that SMRs maintain a good balance of safety, security, and cost efficiency. The major advantage of SMRs compared to other forms of nuclear energy is that they are affordable. Exporters must ensure that the SMRs are as safe and secure as possible, while also not being too expensive. If this balance is achieved, it will greatly reduce proliferation concerns and allow more countries to benefit from peaceful application